So good afternoon, everyone. My name is Pedro Rodriguez. I'm a student of mechanical engineering, and first of all, I want to talk about this project of dynamic design. So the main purpose of this project is to determine the behavior of the of a leaf spring system for Ternium's car. So for this, we need to get some values. So the first thing that we did was some testings with a sensor, and it gave us three samples. The materials that were used were TPU and also Onyx. With this, we put them in the sensor, and then after that, we download an Excel file with the time and the acceleration. We plot the acceleration first, and with the biggest two peaks, we calculate the logarithmic decrement. It is natural logarithm of the peak number 1 divided by peak number 2, and after that we calculate the damping ratio. Damping ratio is crucial for this project because it determines if it's undamped or underdamped, over critically damped or overdamped. Okay. Now with this, we applied certain formulas. Okay, to calculate the coefficient, the spring coefficient K. If I'm not wrong, the formula was 3EI over length cube, and a part of that we calculate, if I'm not wrong, the natural frequency in hertz. After that, the formula of the natural frequency will depend of the type of the beam. In this case, it was a cantilever beam, and after calculating the natural frequency, we calculate the angular natural frequency. It can be the formula that we use was Fn equals to 2 pi by the square root of K by M, if I'm not wrong. After calculating, after this we can calculate omega n, and with omega n, the formula is square root of K divided by M, and we can calculate the mass. After this, we can calculate the damping coefficient. Well, there are two ways to calculate the damping coefficient. One formula is equal to 2m multiplied by the damping ratio, and also multiplied by the natural frequency, the natural angular frequency. Another one is to calculate between the damping ratio between the critical damping. So all of this was possible with some data that we got before. For example, density, dimension for the moment of inertia, and all of that. Well, now talking about the second part of this project is the FEM, or the finite element method, or if you want to call it FEA, finite element analysis. So for this, we need to model the leaf spring as a cantilever beam. The properties depends on, the beam depends on the properties that it was gave us. It depends also of the material, TPU, or if it's Onyx. Part of that, it depends of the properties too. For example, in my case, it was a thickness of 0.3, a length of 80, and the base of 20. After this, we create a mesh, a simulation, and with this we can calculate K. But for this, we need to do a converge mesh. So what is this? So we will increase the number of elements in the beam. For example, if we start with 9,000, in the second one we will do 10,000 elements, and it will go like that until the deviation is less than 0.01%. So with this we can calculate, the main thing that we calculate with this simulation is K. This K we can compare it with the K that we can calculate using the formula of 3EI. E is a Young modulus, I is a second moment of inertia, it can be in Merrill's fourth, and all of that divided by the length cube. That will be all.